Hello, we are going to introduce the machine learning. Introduction to machine learning. Subtitle: Transforming data into a knowledge. Knowledge may be a general science, political science, specific science, universal system, solar system, and so on. We're together with the IT engineer Ilhari Soso. Analyze this picture. We have a robot, and the robot is thinking about some formulas of mathematics. As you know, mathematics is a lesson which is complicated for some people. What is machine learning? Machine learning is a subset of artificial intelligence, AI, that enables systems to learn and improve from experience without being explicitly programmed. Key idea: algorithms that learn patterns from data. Definition of patterns. Patterns are things that happen again and again in similar way. Is things that happens again and again in a similar way. Is things which is trends every time, always. They help us to see how things work or what might happen next. For example, in school, a pattern could be seeing that students get better marks when they do in group studies. There is a table which compares patterns and algorithms. As you know, we are experienced in algorithms when we are a software developer, system analyst, and so on. Consider on the aspect definition: patterns, data-based insights. Algorithm focuses on step-by-step rules. Remember, in algorithms, we use flowcharts to show the representing of hierarchical from one block of administrator to another. Okay. Purpose: identify trends in behaviors. Pattern used to identify trends in behavior. Algorithms solves academic problems like MIS. Information management system, maybe a student management system, maybe a stock management system, student report management system, staff management system, security management system, and so on. Deal with academic problems. The nature: patterns observed in students' actions, while algorithms designed for processes. Algorithms is a series, a sequence of solving problems. Process, step by step. An example of pattern: most students study at night especially in private university. Most students study at night. But in algorithms, steps to solve equations maybe RU decompositions, inverse matrix, quadratic equations, finding the data, and so on. Top 6 formulas pattern recognition algorithms, sequential labeling techniques, classification methodology, regulation techniques, ensemble-based learning algorithms, multilinear subspace learning algorithm, prediction methodology, pattern recognition algorithm MATLAB. You may also visit us for more information on www.phdservices.org. A Netflix recommendation are an example of AI using machine learning. Netflix, as you know, is a platform for video streaming. Self-driving cars. Okay, allow me to play and analyze this video.
Hey, it's Andy with The Verge. I'm about to go for a ride in one of Waymo's fully driverless cars here in Phoenix, Arizona. As you can see, there's no driver in the front. I'm not nervous. Are you nervous? I'm not nervous. Here we are, riding in a minivan with nobody in the front seat, with pedestrians and cyclists and other vehicles out on a public road. It's a surreal experience. Google has been working on self-driving cars for over 10 years now. In 2016, Google spun out its project as a separate company called Waymo, and since then it's been testing hundreds of vehicles here in Arizona, mostly for an Uber-like ride-hailing service called Waymo One. A few years ago, I had the chance to ride in one of Waymo's driverless vehicles, but it was on a private and closed course. And since then, most of the trips that Waymo does in its autonomous vehicles, including the one that we took last year, have trained safety drivers in the front seat. Until now. It says, good morning, Waymo rider. Our destination is Baby K's Cajun Kitchen. It's asking me to start the ride, so let's do that.
Heading to Baby K's Cajun Kitchen. Please make sure your seatbelt is fastened.
All right, so we're pulling out of this parking lot right now and onto public road. Oh, there goes another Waymo car. As you can see, we're in Waymo Central here. They just waved to us. I don't think they knew that maybe there wasn't anybody in the front seat there. And now we just made a right-hand turn and changed lanes into the center lane. It's very natural. So here we come, some construction right here, which is...
Okay, thank you. Machine learning may be used in email filtering when you deal with a spam, anti-spam filter. What is a spam filter and how does it work? What is an email spam filtering? Suppose you send to me the email. Before I see the notification, the spam filter deals with filtering the address of this message you sent to me. May be allowed when the filter, after filtering the spams with a zero viruses, it will allow to be kept in a box. When it detects any virus, the spam, not at all, will keep in spam folder. Is one menu of email dashboards. Okay. Types of machine learning. We move forward. Supervised learning. When we did on supervised learning, we think about two things. We have a labeled data input, which is mentioned clearly, and output is mentioned clearly in the names, type, and kinds, which has different features which is mentioned clearly. Example, predicting a house prices. The house has a clear location name. You may click here to see more about supervised machine learning on YouTube. Okay. This is how to analyze data of machine learning. Machine learning data analyst. The daily work. Supervised learning. Suppose you have a supervisor. Supervisor needs to train a dataset. The desire is to get an output. You have input data, different kind of fruits, mango, orange, avocado, apple, and so on. Use our algorithm, machine learning algorithm. After use a step by step for solving equations, you will move forward to processing. After move forward to processing, it is processing that kind of input data of fluids, raw data of fluids. After, it will produce a desired output. You have three main categories of fruit: mango, avocado, apple. Thank you. Unsupervised learning. We have no labeled output. Finds a patterns in a data. An example, customer segmentation. You may click here to see how unsupervised learning works. Or no, your YouTube. An example, we have a robot which is preaching. This robot is a lecturer robot. Will teach mathematical, will teach chemistry, biology, machine learning, include also AI, and so on. Okay. This is an example of unsupervised learning. We move forward on reinforcement learning. Reinforcement learning is a learning through trial and errors with feedback rewards. An example, AlphaGo. Suppose we have a self-driven car. We have a self machine which work everything there without an explicit of a programmer or a user. This is the reinforcement learning example. Okay. Allow me to visit the industry, modern industry hours today. Suppose we have a self-work machines which cover the container of some products. As you see, there is no people around. The machine work everything at a time clearly. Yes, those are the good effects of machine learning, especially in a type of reinforcement. Okay. Key concepts in machine learning. Number one, consider or no dataset. Dataset is the input data used to train a model. If there is no dataset, machine learning and artificial intelligence not work clearly. Features, variable or attributes in a dataset. Model, a mathematical representation learned from the data. Training and testing. Training, what do you mean if you say training? Training is a teaching the model using a data. Testing is evaluating the model's performance. Evaluate how our model performs. Is it underfit, overfit, best fit? Okay. We move forward on the basic formulas for training and testing in machine learning is number one, total data equal training data plus testing data. Total data, training data plus testing data, where training data is used to teach the model. Testing data is used to check how well a model works. A simple explanation of training, test, train, test, spirit, function. Okay, we have actual Y and predicted Y. Actual Y is a Leo action, a Leo solution we have. Leo data. Predicted Y is the result will be predicted based on trained dataset. You have, as we mentioned before, we have training set on 70% and the testing set on 30%. We have XY custom run, X1 custom 2, X1 custom 3, X1, X1 custom 4, X1 custom 5, X1 custom 6, X1 custom 7, and X2. X2 custom 1, X2 custom 2, X2 custom 3, X2 custom 4, X2 custom 5, X2 custom 6, X2 custom 7. Actual Y. Y actual custom 1, Y actual custom 2, Y actual custom 3, Y actual custom 4, Y actual custom 5, Y actual custom 6, Y actual custom 7. Okay, testing set. We have X cast 8, X1 cast 9, X1 cast 10, X2 cast 8, X2 cast 9, X2 cast 10. y actual cast 8, y actual cast 9, y actual cast 10. Then y predict cast 8, y predict cast 9, y predict cast 10. Thank you. Okay, machine learning workflow. If you say machine learning workflow, you may focus on the following processes. First of all, problem definition. Why? Using machine learning, we deal more than one problems in society. Problem definition, second, data collection and pre-processing is the way of gathering information from somewhere around the world, depending on your forecasted problem. Model selection, you may select one or more than one model of machine learning for training your model. Training your model, evaluation, and turning that model, then deployment. There is other, but now today we focus on the main machine learning workflow. Okay, allow me to start on problem definition. Suppose you are a user, you are a developer, machine learning developer. You face in the essential and crucial problem. Problem statement, list the possible problems. Okay. Problem solving has the 4 steps. First of all, define the problem. Second, generate solution. Third, select a solution. Lastly, as a fourth, apply the solution. Define a problem, generate a solution, select a solution, apply the solution, implement. Okay. Types of problem. Okay. Simple or short description of the item. Simple problem. Short description of the item. Complex problem. Short description of an item. You may describe your own. Wicked problem. Also, you may type or write a short description of your problem of the item. Data collection and the pre-processing. You have web scraping. We're gonna search using search engine, maybe Shopzilla, Amazon, Google, and so on. Type your website, maybe http://www, continue your domain website. You may collecting information from the books, news sources, newsletters. You may use social media, email, Twitter, Facebook, internet, Or you may use HTML, RSS, you may use data of charts, may use company information. Those are the kind of searching information, data collection. Data preprocessing. Data preprocessing is a pipeline of filtering, processing, analyzing, reshaping, cleanup of your data for better meaningful. Okay, those are the data preprocessing. We have kind of informations we put in our filter for one better desired output. Focused on recall solutions of that problem we defined before. Model selection. Evaluation, depending on quality of model, criteria, analysis, accuracy, assessment, accuracy, audits, accuracy, results, performance, and improvements. Okay, training the model. Okay, suppose you train the model with your test size, optimal training size, correct using graph. Okay, accuracy per year, time, the accuracy will decrease when the time is long. Accuracy per month, when time is long, the accuracy will decrease per month. Suppose you have a real estate, you have a purchase online product. You may purchase a product in Amazon websites. You may use a Shopzilla and so on. Okay, on model training, we have input data. Our data is a data set also. We select a model 1, version 2, for processing and filtering, evaluating that data set for a best desired output. After model training completes work, it will move forward or no prediction, forecasting the future desired needed. Act or show prediction, yes. Model 2. Should we trust the model 1? No. 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 No prediction or far back. Numerical classifier, cosine, MMD, Euclidean, question mark. Which is suitable you will use? Evaluation and the turning. Evaluation and turning. Configurations. Client pool. Evaluation sample for smartphone. using graphical representation, bar chart, server, aggregated linking, engine evaluation, data source, training data, data preparator, prepared data, algorithm 2, algorithm 1, algorithm 3, predicted results depending on model 1, 2, 3. Serving we have query 1, query 2, query 3, actual result 1, actual result 2, actual result 3, evaluates. We have predicted result 1, predicted result 2, predicted result 3. Evaluator, query 1, actual result 1, comma, predicted result 1, query 2, comma, actual result 2, comma, predicted result 2. Query 3, comma, actual result 3, comma, predicted result 3. Matrix, evaluator results. Deployment. Application deployment for users and the environmental implementation. Okay, the best operating system merging and deployment software. Okay, we did on deploying our machine learning projects. Common algorithms used in machine learning. In supervised learning algorithm, we have linear regression, decision trees, neural networks. Linear regression use a graph, Cartesian plane, to have examination score. Start for 35 marks, decreasing depending on a linear equation. Suppose by using the formula y equal b0 plus b1 times x star x. Y intercepts in for x axis and y axis we have 35 marks. There is a student who is studying at a time in the hour of study. When the marks increase progressively or decrease reverse, we focus on linear regression. Marks, is it increase or decrease? Linear regression in machine learning. We can focus on a correlation, some relationship of 4 items. We have the different mixtures of circled images for y-axis and the x-axis. The linear regression will use a line straight which is diagonally passing through for that images which is circled green. Decision tree. Suppose we have a tree containing fruit of social media items and formations, search engine informations. This tree, suppose you may compare as a Google search or ChatGPT or Wikipedia, and so on. Everyone search. Those are the kind of decision tree. Decision tree by graph, flowcharts. Decision tree structure, root. You have a root. Yes. Will you move forward or no? Leave. More than 10 p.m. Condition is no. Will you move forward or not? Yes. Will you move forward or not? Leave. No. Will you move forward or no? We have reached the stopping criterion. Leave. Okay. We have a root with the parallel leaves, leaf nodes, with the parallel nodes, internal nodes 1, internal nodes 2. We have a leaf on the left side, on the right side, we have a leaf again. Internal nodes on the right side has internal nodes again. Internal nodes have the 2 leaves on the right side and the left side. Okay, thank you. Neural networks. Neural networks works like a human mindsets, human connectivity of neural networks. You have input features, as you see here, input features. You have our biases, hidden layers, roots of layers, deep learning models. Deep learning means running deeply for special discovering a new things from existing things. Okay, we have an output. The desired output predicted is 2. We input 1, 2, 3, 4. Then deep learning, hidden layers deal with processing using a neural network. Then output desired of prediction is 2. Yes. Where other 2 left it? Okay. Okay. Neural networks from the ground up. Okay. Artificial neural network. X1, X2, X3, and so on, continues to Xn. Have W power 0, W in prime. Okay, hidden layer 1, hidden layer 2. I/P layer as the input layer. Okay, W power M, you have hidden layer M. The result, the prediction will be Y prediction. Unsupervised learning algorithms, K-mean clustering, principal components analysis, PCA. K-mean clustering. Before K-mean, have ungrouped circled green images. After applying k-mean, we have a grouped circled images. We have black circled circle shapes. We have blue and green. Clustering means to group the things with the same criteria, same features, same kinds, same categories, same types. Before applying k-mean clustering, we have the mixed shapes. After clustering, cluster 1, we have a red circle. Cluster 2, we have a green circle. Cluster 3, we have a blue stars circled or grouped. Principal Component Analysis, PCA. Principal Component Analysis, PCA. The Principal Component Analysis, PCA transformation original data high dimension. You have 3 dimensions. Variable 1, variable 2, variable 3. In the inside you have Principal Component Analysis, PCA. PCA 1, PCA 2. Okay. PCA dimensionality reduction. You have 3 dimensions, then we are going to reduce dimension size shapes. Lower dimensional embedding. We have principal component 2 on the y-axis, principal component 1 on the x-axis. Okay, then PC2, principal component analysis 2, will be a vertical line with a blue color. PC1 will be a horizontal line with a red color. Minimize the variance around PC1, minimize residual along PC2. Thank you so much. Treatments, control, salinity, contribution, 2, 3, 4, 5, 6. Okay. You have PC2 on 20.6%. Total now, short now, root now, on a circled green shapes, which is salinity. RSR has an intersection. On the x-axis, we have a PC1 on 54.4%. We have SDW, TDW, RFW, TFW, SFW, RDW, SR, RR, A, short key, total key, kina, root key, SPAT. Reinforcement learning algorithms, Q-learning, deep learning, reinforcement learning. Q-learning, we input tomato response. We input unlabeled data, maybe mango or tomato. Response Question, it is a mango. After analysis, it is a mango. Feedback, wrong, it is an apple. Yes. Response without machine learning, it may get too long. Input, exactly. Our traditional computer says it is a mango as a response. But after analyzing, the feedback will be wrong. It's an apple. Running, noted. Reinforced the response. It's an apple. Input. It's an apple. Okay, agent. Environment deals with an agent. Actions, rewards, observation. Key learning algorithm. Solved example 1. We have this kind of shape. Okay. Deep reinforcement learning. We have agent DNN police. Okay. PyQ S, A state parameter Q take action observe state environment rewards. Agent state observation action environment rewards. Observation UN equal on.u environment UN and so on. Okay. Thank you for today. We will continue on applications of machine learning.